Hello, welcome. My name is Michael Holmberg, and I'm going to talk about the data center network architecture and requirements for 5G. So, as I only have like 10 minutes for this, it's a fairly high-level kind of walkthrough, and I'm basically going to focus on automation from that piece. Now, my apologies. The first slide was supposed to have a animation here for the fabric automation basically. But I'm coming later on in my presentation to another slide where you basically see it. So with that said, let's dig in. So we see the, kind of automation as a journey. So basically you start from you start from somewhere. So today you start from a basic, automation that might be just for the network part. You have some in-house built script or something like that. So truly kind of the introduction to automation. Next phase is that you go into the more comprehensive automation where you start to use your Python scripts, your Ansible playbooks, things like that. All of these are still like network automation. Then you go into the next phase, which is then basically, something called a cross-domain automation. Now, what is cross-domain automation? Think of this as, the IFTTT part. If this, then that. Which basically means that you look at not only network automation anymore, this gets into a closed-loop automation, where you could obviously automate your fabrics and your infrastructure, but you could also add applications and remediation and things like that into the automation phase. So what do I mean with that? What I mean is that basically assume as an example that you have a network infrastructure in place, you have a fabric, for instance, in place. Now assume that you have a problem on a connection. You have slow connectivity, for instance. What you can have is webhooks into applications that would allow you to kick off a packet capture, for instance. And then obviously, do packet captures and analyze the result of that. You could have webhooks into other applications, being a Slack channel, right? Where you would post some Slack messages onto a given channel for your NOC, for instance. And then you could have automatic remediation taking place, which basically means that I'm going to post a message somewhere saying I have a problem. I'm going to kick off an application that might be a packet capture, and I'm going to actually have a webhook into a trouble ticket system, for instance, that would open a trouble ticket for me. So this is closed loop automation. So just to kind of build a picture here. Moving ahead on this, so when we start to talk about network automation, obviously my presentation is based on kind of the extreme network automation for the fabric part. So I'm going to focus on a data center fabric, which basically means that this is a kind of new innovative fabric automation that we talk about. It's based on microservices architecture. And obviously it's high performance with low resource utilization and a minimal touch point. So let me get the build up here. So what that means is that it provides a REST API that I can have a integration northbound to some OSS systems that would allow me to orchestrate the fabric. I could also use, the CLI. If I have DevOps people in-house, I could obviously use the CLI part for that one. Now, the fabric automation. So let me actually rephrase this. So I'm kind of building the foundation here for the next slides I'm coming to. But the fabric automation is basically based on multiple things. You have the asset services, which is basically the source of truth for all the services you're going to provision. Then you have the fabric and tenant services, which are pretty much, self-explanatory in the sense that fabric services obviously creates the fabric, while the tenant services, orchestrates the tenants into the fabric. Going to the next slide. So looking at this from a 5G point of view, obviously today with 4G you have a couple of or not that many data centers. So automation obviously is still kind of key. But moving to 5G, as we all know and understand, what you'd have is obviously thousands of micro data centers in the edge cloud, which means that automation actually have completely new requirements here. And that's where we kind of see this fabric automation being a key part of that. So the problem we are trying to solve here is that network provision is slow, complex, and time-intensive, and always subject for errors due to the fact that humans are configuring the stuff. What this slide kind of tried to describe here is that on the left-hand side you have your hyperconverged infrastructure virtualization admins working on their platforms. Then you'll have your network admins working on the network part, right? And then eventually you have your network. What happens is that obviously I need to provision and orchestrate my network, my fabric for different services. Or if we take a step back, before you even get to the services, you need to provision and orchestrate it for your basic foundations, right? You need to build your VLANs. You need to build your port channels, your IP underlay, your overlays, you name it, all those different things. Now, as we all know, it's not a trivial task, which actually, allows for human errors when you configure this. And at the end of the day, it might take days or weeks to orchestrate and provision this. Now, we are trying to solve this problem then by introducing something called the Extreme Fabric Automation, which as a platform or an application as it is, provides connectivity for your network admin, as well as obviously for your app and platform and server administrators. So you have an API into your virtualization platforms, and then obviously you have a interface from the network operator, orchestrator into this one. So me as a network operator, I can use CLI, jump onto the Extreme Fabric Automation application. The same thing with the app server here. He basically works with his hypervisor platforms. And what you'd have is then obviously some southbound APIs into the fabric that will automate the day zero provisioning orchestration of the fabric, meaning that I'm going to build my VLANs, my IP underlays, my overlays, all of those different things I'm going to basically automate within my network, which basically means that you get rid of the human error possibility here because everything is automated, both from a infrastructure fabric point of view, as well as obviously from the tenant side and the virtualization platform side. So what this leads to is you go from days or weeks of provisioning to basically seconds of provisioning due to the fact that everything is automated here. So kind of a overall overview of the Extreme Fabric Automation. What you can see here is that it's obviously based on microservices. So you can see the foundation services as I described. You have your asset services, you have your fabric infrastructure services, and you have your tenant services. Now, obviously, the asset is discovery. So I'm going to discover my fabric as such. The fabric is building the fabric, and then obviously the tenant services is mapping the attachment points to the services I have in the network or in the fabric. Now, obviously, you have the integration to the ecosystems as I was mentioning. You can have this on-box or off-box. What does this mean? On-box actually means that assume you have a switch, a network switch. You have a virtual machine running on that one, something called a TPVM, third-party VM, which would host that application, which means that I can run this application within my fabric. So I'm not going to add any compute overhead due to the fact that I run it within my fabric. Or I can run it off-box, meaning that I can run it on a compute node somewhere in my infrastructure. I have both options. Provides me with high availability and federated services via Kubernetes clusters. And then you go into these different kind of capabilities. I'm not going to go through those now. But generally speaking, putting this into some context. So what this shows you is how this actually happens. So obviously today, you start with building your top-of-rack switches. You connect in your hosts, which for redundancy perspective are dual home. You use MLAG, MCT, something like that on layer 2. You then connect in your leaf-to-spine connections, so physically connect your cables. Then you connect your management network, where you basically have this application running. Okay, so this is my infrastructure now. The next phase is my day 0 orchestration and provisioning. So what I'll do is assume I'm a network admin now. I'll use the CLI. Could be also using the northbound API for a given application. But I use the CLI to kick off basically the creation of the fabric. So what you can see is a single command where you define it's a stage 3. So this is a CLO architecture, leaf spine architecture. It defines as a 3-stage CLO architecture. The next thing is that I define my spine and leaf switches. And then I basically define the name of the fabric. I'm done. I basically created my fabric now with just kicking off this application that could be running on one of the switches. So I could use one of the switches to host this application, right? Okay, so I have my underlay, my switch fabric is built now. Next thing I'm going to do is orchestrate my tenants, right? So what I'll do is a couple of commands. The first one, I define a physical port for my tenant. So how is my tenant going to connect in here? I define the port and the VLAN tag for that. And then I'm basically going to map it to an overlay here. So now I basically have my day 1, day N orchestration taking place, right? So this is basically now how I built the fabric underlay and the overlay using this application. So going back to this kind of architectural slide on this, what you'll see is kind of the same representation you saw earlier on. You have your ecosystem integration here. You have your northbound API, which provides a RESTful API, which allows me to use third-party applications or OSS systems to actually talk to this. And then the southbound device API talking down to the fabric, provisioning the fabric itself. And the tenants, obviously. Then you have the foundation services, as I mentioned, 3 of those, the asset, fabric, and tenant. So what it basically means is that on the asset side, you have, creation of the VLANs, the bridge domains, your BGP configurations, kind of different assets you have there. On the fabric services, obviously you define if it's going to be a 3-5-stage CLO architecture, a non-CLO architecture, so how you would build that fabric. And then eventually your tenant-aware services is mapping the attachment points into this fabric. So this is the slide you should remember from this presentation. This is the overall view of how the EFA, Extreme Fabric Automation, actually is built up. So with that said, this is kind of a summary of this. So what it basically says is that the only network fabric solution with built-in automation. As I tried to describe to you, you can have it embedded into the fabric, or it could be off-box from the fabric. It orchestrates both the fabric as well as your day 1 and day N tenant and attachment points into the fabric. Plug and play, as I kind of walk you guys through. Reliable provisioning due to the fact that the human error factor is close to 0 here. And some quotation from Gartner here, which is pretty interesting. I'm not going to quote those, but you guys can read that. But that basically says that automation is key. And if you look at this one, a key finding is approximately 70% of data center network tasks are performed manually, which increase time, cost, and likelihood of errors today. Obviously, solution or recommendation is reduce cost, improve agility, and minimal faults by implementing automation, orchestration, intent-based networking, which is basically what I kind of went through here with the Extreme Fabric automation. So with that said, this kind of concludes my presentation as a high-level overview. Any questions? If not, then thank you. Boxing. White boxing. The question was, do we support white boxing? We do support in the future white box as well.